Isang mapagpalang araw, my dear students. So in this new lesson video, we will be discussing about stoichiometry. So this stoichiometry will be based on balanced chemical equations. So expect that this video will present calculations involving mass, mass, mass volume, and volume, volume relationship. So we know that a chemical equation describes what happens in a chemical change or in a chemical reaction. A chemical equation shows not only the kind of the substances involved in the reaction, but also the relative amounts of the substances. Why is that so? Because the coefficients written before the formula in a balanced equation represent the number of moles of each substance involved. And since the number of moles is related to the mass of any substance and to the volume of any gaseous substance, then it is safe to surmise that the mole relationship can easily be changed into mass-volume relationship. So I have outlined here steps in solving problems involving stoichiometry. So first, we should be able to write a balanced chemical equation to represent the reaction involved. So mahalaga na balance yung equation. Bakit? Kasi importante na makita natin yung relationship, no? Yung molar relationship ng lahat ng substances involved, no? Makikita lang natin yun kung tama yung mga coefficients na nakalagay at balance yung ating equation. Step 2 is to be able to express the given quantity in moles. No? If the given quantity is mass, the conversion factor is the molecular weight. However, if the given quantity is volume at standard temperature and pressure, the conversion factor should be the molar volume. Now, what is the molar volume? The molar volume with equivalent of 22.4 liters is the volume occupied by 1 mole of any gas at STP. So that is 0 degrees Celsius and 1 atmosphere pressure. Third step is to be able to convert the number of moles of the given substance to the number of moles of the unknown substance using the coefficients in the balance equation. And the last step is to be able to express the number of moles of the unknown in the desired unit using the conversion factor we described in step 2. So, bali ang mangyayari, may given quantity. No? Yung given quantity ang gagamitin natin para makuha natin yung desired quantity. Now, yung unit lagi pa ng given at ng desired, ang relationship nila ay number of moles. So, kung ang given ay hindi in terms of number of moles, dapat ma-convert natin kung ano man yung given into the number of moles. So, makukuha natin yung number of moles ng unknown at yung number of moles ng unknown na yun naman ay i-convert ulit natin kung ano yung desired sa atin, whether mass or volume. So, let's have some examples. For number 1, the fermentation or the conversion of glucose C6H12O6 with molecular weight 180 gram per mole to ethanol C2H5OH with molecular weight 46 gram per mole and carbon dioxide CO2 molecular weight 44 gram per mole is represented by this equation. So we have C6H12O6, so this is glucose in the solid state, decomposed into C2H5OH. So this is the fermentation process. So C2H5OH, which is ethanol in the liquid state, plus carbon dioxide in the gaseous state. Now the question is, how many grams of ethanol can be produced from 1 kilogram of glucose? So kunwari meron kang 1 kilong glucose, no? Gaano kadaming ethanol ang mapuproduce, no? Ang tanong ay grams. So how many grams, rather, what's the mass, no? What is the mass of ethanol equivalent to 1 kilogram of glucose? Bali, yun yung tanong sa atin. So, applying the 4 steps, we should be able to write first the balance equation, no? So, by inspection, we know that we need to affix 2 to ethanol and also 2 to carbon dioxide. So, let us check. We have C6, we have 2 times 2, That's 4 carbon plus 2 times 1. So that's 2 carbon. 2 plus 4, 6. So carbon is balanced. Hydrogen is 12. So we have 2 times 5. That's 10. Plus 2 times 1, that's 2. So 10 plus 2, that's 12. Hydrogen is balanced. Oxygen is 6. So we have 2 times 1, that's 2. 2 times 2, that's 4. So 4 plus 2, we have 6 oxygen on the right side. We also have 6 oxygen on the left side. So everything has been balanced. The next step is to be able to express the given quantity into the number of moles, okay? Into moles. So ang binigay sa atin ay 1 kilogram ng glucose. So yung mass ng glucose, convert natin yan sa moles. Paano yan? Remember that the number of moles is equal to the mass over the molecular weight. Okay, so the mass is given with a value of 1,000 grams, so 1 kilogram, so that's equivalent to 1,000 grams. Bakit ginawang grams? Kasi yung molecular weight in terms of gram per mole, para ma-divide niya, no? Yung gram. So we have 1,000 grams divided by 180 grams per mole, gram would cancel out. So gram divided by gram, no? So 1, sagot ay 1, times mole. So the number of moles of glucose equivalent to 1 kilogram of glucose, no, is 5.56 moles. The third step is to be able to calculate the number of moles of ethanol equivalent to the given amount of glucose. Paano yun? Sa balance equation kasi nakikita natin yung 1 mole of glucose is equivalent to 2 moles of ethanol. Meron tayong 5.56 moles of glucose. Ang tanong, ilang ethanol, no? Ilang moles ng ethanol ang equivalent dyan sa 5.56 moles. Yun yung isa-solve natin using the relationship, no? From the balance equation. 1 mole of glucose is equivalent to 2 moles of ethanol. And therefore, the number of moles of ethanol is equal to 5.56 moles of glucose times. Parang ratio and proportion siya, no? So yung unknown natin nasa taas, yung glucose would divide itself. So ang matitira, yung desired unit number of moles of ethanol. So 5.56 times 2 upon 1, so we have 11.12 mole. Ang tanong sa atin, mass ng ethanol. So itong number of moles ng ethanol, i-convert na naman natin sa mass. So that's the fourth step. Calculate the mass of ethanol using its molecular weight. So the mass of ethanol now is the solved 11.12 moles times the molecular weight of ethanol, which is 46 grams per mole. Mole would divide itself, and therefore we have the desired unit grams, which is clearly a unit for mass. So we have 511 grams of ethanol. So this is the amount of ethanol produced if we have 1 kilogram of glucose. Ang dali lang, no? Yung nakakatuwa lang, parang umiikot ka lang, parang cycle lang siya. Given, gagawin mong moles, tapos hahanapin mo yung moles ng unknown equivalent doon, tapos ibabalik mo na naman siya, convert mo na naman siya sa desired quantity. The second problem, for the reaction, 4 moles of ferrosulfide plus 7 moles of oxygen, we will produce 2 moles of ferric oxide plus 4 moles of sulfur dioxide. We are asked to calculate the number of grams of oxygen that would be needed to produce 8 moles of sulfur dioxide. So, hindi ko na isusulat yung step 1, 2, 3, 4. No? So, isipin na lang natin kung ano yung mga steps na yon. So, we are given 8 moles of sulfur dioxide. We are required to find the mass of oxygen which will be needed to produce this much sulfur dioxide. Remember, sulfur dioxide is a product and oxygen is a reactant. No? Again, we use the formula. So this is the heart and soul of stoichiometry, this equation. So dapat matandaan natin tong equation na to. Number of moles is equal to mass over molecular weight. And therefore, the molecular weight is simply the product of the number of moles and molecular weight. Okay, so the mass of oxygen, the required mass of oxygen is, so this one, 8 moles of sulfur dioxide times 7 O2 upon 4 SO2 represents, so this product represents the number of moles of oxygen. Okay? So, kung yung 4 moles of sulfur dioxide equivalent sa 7 moles, so yung 8 moles equivalent siya sa ilan? Parang ganun. No? So, 8 moles of sulfur dioxide times 7 moles of O2 upon 4 times 32. So, yung 32, ito yung molecular weight. So, yung N, ito yon, no? So, I hope nakikita yan, no? So, we just multiply 8 times 7 times 32 divided by 4. So, we have 448 grams. So, ibig sabihin, kailangan natin ng 448 grams of oxygen to be able to produce 8 moles of sulfur dioxide. And then, we have the third problem. Iron is produced in a blast furnace by heating hematite Fe3O4 with carbon monoxide. How many liters of carbon monoxide measured at STP are needed to produce 5,000 grams of iron? So again, we abstract the data. So given mass of iron, which is 5,000 grams, and we are required to solve for the volume of carbon monoxide needed, no, in terms of liters. Okay, so the balance equation is written here. So we have 1 mole of hematite plus 4 moles of carbon monoxide to produce 3 moles of solid iron plus 4 moles of gaseous carbon dioxide. We will only be needing the relationship between carbon monoxide and iron. So we have 4 carbon monoxide, 4 moles of carbon monoxide equivalent to 3 moles of iron. Eh, ang binigay sa atin, hindi naman moles, 5,000 grams ng iron. So dapat alamin natin yung equivalent na number of moles sa 5,000 grams. So paano gagawin? So yung formula, no? Na mass over MW. Okay? So to be able to solve for the number of moles of carbon dioxide, so we need a ratio and proportion equation such that the number of moles of iron times 4 moles of carbon monoxide divided by 3 moles of iron should be used, no? So ito yung magre-represent sa number of moles of carbon monoxide equivalent to 5,000 grams, no? So yung number of moles of iron, masosolve natin, no? We can solve that by dividing the mass divided by molecular weight and multiplying that with 4 moles of carbon monoxide upon 3 moles of iron. So substituting, so yung mass ng iron is 5,000 gram divided by the molecular weight or atomic weight kasi mag-isa lang naman si carbon. Atom lang siya. So we have, hindi ko na lang binago yung formula, no? But technically, this is atomic weight kasi atom lang siya, hindi siya molecule. So we have 55.85 grams. Saan nanggaling yan? Sa periodic table, no? So 55.85 gram per mole. So gram will divide itself. So we have a unit mole times 4 moles of carbon monoxide divided by 3 moles of iron. So ano to? Number of moles of iron. So di-divide niya yung sarili niya. Matitira moles of carbon monoxide. So we have 119.04 moles. Di pa tayo tapos dahil ang gusto natin ay volume. So yung number of moles ng carbon monoxide, imumultiply natin sa molar volume which is 22.4 liters per mole. So mole would divide itself. Anong natirang unit? Liters. So we have 2,666.5 liters. Ano yung sabihin nun? Kailangan natin ng 2,666.5 liters of carbon monoxide to produce 5,000 grams of iron. Okay? So, I hope malinaw, no? Sana malinaw ang pagpapaliwanag. So, I'd like you to solve these 2 problems as your seat work and as an exercise. No? I'll give you a copy of these problems. Okay? So, thank you for listening. You stay safe and you stay healthy, class. See you when I see you. So, bye for now. Please stay safe and stay healthy.